This video, made in 3 parts, is for the students who are preparing for the test on linear equations and functions. If you are familiar with the concepts of linear equations and functions and look for additional tips on graphing, you may find this video helpful. Let's say you have to graph a linear equation of the form ax plus by equals c, where a, b, and c are integers. You probably already know that the graph of this equation is a straight line. Moreover, to graph a straight line, you only need 2 points. Sometimes we're asked to find additional points to make sure that our calculations are correct. However, 2 points are necessary and sufficient to graph a line. So how can you find these 2 points, actually called ordered pair solutions? The answer is very simple. Plug any value for x into the equation and solve the equation for y, or vice versa. And here's where I would like to make a suggestion. To make the graph more accurate and more precise, use order paired solutions with integer coordinates. Why integer coordinates? To minimize the error. Let's look at these 2 order pairs. One on the left with coordinates 3, 5 has integer coordinates, and the other on the right with coordinates 3, 17, 12, 19 has the coordinates that are fractions. Perhaps many would agree with me that to plot the first order pair is a lot easier than to plot the second. So I would like to offer 3 examples of linear equations of the form ax plus by equals c, and I will graph them using only order pair solutions with integer coordinates. To start, I will always find the intercepts, points at which the line intersects the x and y axis. Quick reminder, to find y-intercept, we let x to be equal to 0 and solve the equation for y. And to find x-intercept, we let y to be equal to 0 and solve the equation for x. So let's start with our first example. And to find y-intercept, we are going to let x equal to 0. So 3 times 0, which is equal to 0, plus 4y equals 12. Now the x term disappears now. We end up with 4y equals 12. Now to solve for y, we need to divide both sides by 4. So y is equal 3. So our y-intercept is 0, 3. Now let's find the x-intercept. We're going to let now y to be equal to 0. So 3x plus 4 times 0. 4 times 0 is equal to 0, equals 12. So 3x is equal to 12. Divide both sides by 3. X is equal to 4. So my x-intercept is 4, 0. I will put my intercepts into the table, and I'm going to move now to my second example. 2x plus 3y equals 0. So again, I'm going to start by finding my y-intercept. I will let x to be equal to 0. 2 times 0 is equal to 0, plus 3y is equal to 0. So I end up with 3y is equal to 0. Divide both sides by 3, and I will have y to be equal to 0. I hope you recognize that my y-intercept, in this case, has special coordinates, 0, 0, which means that is actually my x-intercept as well. Moreover, the point with coordinates 0, 0 is called origin, which means that my line is going through the origin. But if you did not recognize it right away, we can actually find the x-intercept just like we did in the previous example by letting y equal to 0. So 2x plus 3 times 0. 3 times 0 is equal to 0, equals to 0. And we're going to end up with 2x equal to 0. And what do I see? My x is equal to 0. And again, I will put my intercept in the table and move to my third example. Negative 7x plus 5y equals 6. Let's start again with y-intercept. We're going to let x equals 0. Negative 7 times 0 is equal to 0, plus 5y equals 6. So 5y is equal to 6. Divide both sides by 5. Y equals 6 over 5. And to find my x-intercept, I will let y to be equal to 0. So 5 times 0 is equal to 0. I will end up with negative 6x equals 6. If I divide both sides by negative 7, I'm going to have y to be equal negative 6/7. And again, plot them in into the table. And I will continue by graphing my first example. So this is one of those fortunate cases when both intercepts have integer coordinates. So those are easy to plot and sufficient to graph. So I'm going to plot them on my coordinate plane. First 0, 3, and then 4, 0, and I will connect them with a straight line. Here's my first graph.